do them as well as you possibly can. Okay. Okay, I am going to now have a look at that question on the 6C and 6D, because 6C it looks like a nice easy question, but there's a bit in this one. There's a lot of ways you can get this wrong, so let's have a look. So how do we do domains? We know domain is the x values that can go into the function. So we want to know here, what x values can I put into this particular equation here so that it works? What are the x values that I can put into the equation? Okay, so I know when I square root that in a square root, you can only square root in methods, 0 or positive numbers. Okay, so 0 positive numbers. So in this case here, that means that 2 take x squared has to be at least 0. The result of whatever x you put in, when you do 2 take x squared, you have to get a positive, have to get 0 or bigger. So let's work this through, because it's not as simple as it looks. There's lots of maths I'm going to do here. So hopefully you can keep up as I go here. I'm going to take the 2 across the other side. So I have negative x squared, negative 2. When I divide by -1, remember you change sign. When you divide by negative, you change the direction of the inequality sign. Now, the big danger here is people say, therefore, x is less than or equal to root 2, and that is wrong. Okay, so I'm right to there, but that last statement there is wrong, and that's a mistake that a lot of people will make when they do these questions here. Okay, even if you go, oh, hang on, yes, squared, I need to do that plus or minus thing, don't I? If I do this, that's also wrong. Okay, bother. All right, what do I do then? If I'm less than root 2 and I'm also less than negative root 2, maybe it's less than negative root 2. That covers both. That's also wrong. Lots of ways of getting it wrong. How to get it right? Well, it comes back to this, folks, and this is really important, and I can't stress how important it is to get these things right. These are tricky. What we've got here is a basic, but it's a quadratic inequality, a quadratic inequation. And these are devilishly tricky. These are devilishly tricky to do. So you're going to be really on your game here. The way to do these is step 1, solve the quadratic equation. The equation, not inequation. Solve the quadratic equation and then use your graph to find your region. Okay, so this is the method that I recommend strongly. I can tell you from doing this 27 years that students who do this method here tend to get these questions right. So if you have your own method, that's fine. But if you're not sure about these, or you're a bit haven't been too good at these ones, this method works. So from here, what you should do is this, is change this into, so you say let x squared equal to. So change your inequation into an equation, from inequation to an equation, and solve that. That's an easy solve. That means x equals plus or minus root 2. And if I write let at the front, I can do that and change the question slightly. Once you get those two x-intercepts, I'm saying use the graph. We'll use what graph? We're going to use the graph of, where's my 0? Oh, okay, I'll use this graph up here, okay? The very first graph. There's my equation there, there's 0 in it. Okay, I'm going to use that graph there. I'm going to graph y equals 2 minus x squared. Not the square root, forget the square root for now. We're just working with the inside. So 2 minus x squared is an upside down parabola. I shift it up to like that. Now, we're trying to work out when is it greater than or equal to 0. Now that, folks, is the bit above the axis. This part here, here's the solution set here, the part above the x-axis. So the x values lie between the two x-intercepts. And the two x-intercepts we've already found. Here are the two x-intercepts over here, negative root 2 and positive root 2. So the correct solution to this is that x has to lie between. So that one continuous region lies between negative root 2 and positive root 2. For all the x values between negative root 2 and positive root 2, the graph is above the axis. It's greater than 0. Repeat, between negative root 2 and positive root 2, the graph is above the x-axis, therefore the values are positive. So the final answer is negative root 2, x, positive root 2, which is different to all of those incorrect answers that I wrote down earlier. But that's a lot of working there for potentially 1 mark. So please be aware of these things here. It looks like just a domain question, but the fact that it's a quadratic inequation elevates this to a much harder question. You've got to practice these ones here. In fact, what do you know? Here's a chance to do it again. So 6D, if you haven't done 6D yet, or if you got 6C wrong, go back and do 6D again now, please. So 6D is what I want you to do right now. Find the domain of this one here. Okay, so we're going on number D. Number D here. Pardon me. So again, we've got a square root involved. So we know that we can only do 0 or bigger. But in this case here, we don't include the 0, because if I had, say, x equals 3 would give me x squared take 9 equal to 0, and I can't have 1 on 0. So in the previous question, I said, what's in the square root has to be at least 0. And that's still true, but because of the 1 on, when you have 1 on something like that, that thing there cannot be 0. So in this case here, my x squared take 9 has to be a positive number, not greater than or equal to 0, but greater than 0. Because if it equals 0, you get a 0 in the denominator, and that's a problem. So we solve this one here. Hope you had a chance to do this. Remember, what you do is let it equal an equation like that and solve that. Okay, nice little remembering here. Difference of perfect squares. X take 3, x plus 3 equals 0. So x equals plus or minus 3. So you draw your upright parabola this time. It's gone down by 9. 2 x-intercepts are -3 and pos 3. Now, where is that graph? Again, we go back. In this case here, we're looking for, where is it? Greater than 0. Greater means above, less than means below. Okay, so where is it above the axis? Well, you can see it's above the axis, this bit here and this bit here. So how do we get those x values? That's all the x values back from -3 and all the x values on from +3. So our final answer is going to be x less than -3, because I only want above the axis. I can't have the on the axis. Remember, it can't equal 0. So it's x less than -3 and it's x greater than +3. And again, notice 2 separate regions, 2 answers with a union in the middle. In the previous question, 1 continuous area, 1 continuous region in my answer. Okay, so they're not easy questions. They're not easy questions, but they're the sort of questions you've got to be able to do pretty confidently to be able to work with domains and work with domains well, as I said, in exams and in SACs. Okay, now someone did answer, and I might answer this by verbally rather than typing, sorry. Someone's asked, can you do these sorts of questions on your calculator, work out what the x-intercepts are and then work it out that way? Or do you have to do all the working? Now, you soon have to do all the work in these questions because they're generally only worth 1 mark. So 1 mark questions in the exam, if it's worth 1 mark, you don't need any working at all. We don't look at the working for a 1 mark question. We only look at the answer. So if a question's worth 1, we only look at the answer. Do not look at, if the working's wrong and your answer's right, you get the mark. If your working's right, your answer's wrong, you get 0. It's all about the answer. Questions worth more than 1 mark, though, you must show workings. If it's worth 2 and you just write down the correct answer, you don't get 2 marks for that. You only get 1 for the answer. You get marks for previous things that lead to that answer, okay? So because these are only 1 mark questions, no working required, you can just do the whole thing in the calculator. You can graph it. I know the TI's got a function called, a command called domain. You type in domain, put in the function, it gives you the domain, okay? So, and I'm sure the Casio does the same, similar sort of thing. So no, if you've got a CAS, you just do the working you like and then just write the answer down for a 1 mark question. If it's worth 2 though, you get your answer, you need to write something down on the way. So maybe find something from the CAS you can write down to get that working mark on the way through. So I hope that answers your question.